In this lesson, we're going to talk about graphing absolute value functions. So recall an absolute value in general is always a positive number. So when we look at the parent function of this, we know that all of the outputs have to be positive as well. So our parent function would be f of x is equal to the absolute value of x. Now, on all of the problems we're going to do, keep in mind the domain and the range of the value of the function as well. So if we look here, this symbol represents all real numbers. So any absolute value function is going to have a domain of all real numbers. Now, what will change is the range. And the range is going to be indicated by the vertex and the direction of the function. So in this example, in the parent function, the range would be values of y greater than and equal to 0. Okay. So now what we're going to do with this function is we're going to shift it. And one way we're going to shift it is vertically. All right, so our vertical translation would be represented by f of x is equal to the absolute value of x plus k. So k is going to indicate the value up or the value down. So in this example I gave you, we're going to go up 2 units. So the vertex is going to go up 2 units. Now, it's important to keep in mind as we go through these to pay attention to the slopes of the line from the vertex. Since there is technically no value out front, it's really a 1. And so the slope from that vertex would be up 1 and over 1 in each direction. Okay. The domain again is all real numbers, and the range now is going to be values of y greater than or equal to 2. Okay. All right, now if we shift horizontally, right, we're going to have where we talk about that negative h. It's the opposite of the shift. So we're going to represent it in the opposite direction. So if I have x minus 4, that means it's actually shifting to the right 4 units. So the vertex would go 4 to the right. Again, domain is all real numbers, and the range now is still all the values of y greater than 0. Now if we look here, the slope of this is still 1. So from our vertex, we would go up 1 and then over 1 in both directions to plot our coordinates. Now we go to the reflection. Now this is where the value outside the absolute value is a negative sign. So in this example here, the value would be represented as a, but the first example I want to give you is just a negative, which represents the value -1 for a. So what this is going to do is flip our graph upside down. So it's going to open up and go downwards. So our vertex stays the same at 0. Our graph would go down 1 and over 1 in both directions. And our range is now going to switch. It's going to be the y values less than or equal to 0. Okay, so if we have a negative out front, it's going to flip the graph upside down. Okay, so just to review, we go up and down with translations this way with the value k outside. We can go left and right with the values inside the absolute value. A negative sign out front is going to flip the graph, right? And then we also now can change the slope of the graph. So if the value is a positive number or even negative, we can change the slope. So if I gave you the function f of x is equal to 2 times the absolute value of x, what's going to happen is that in this case, it doesn't translate up and down or left and right. So the vertex stays at 0, 0. What changes is this 2 means we're going to go up 2 and over 1 unit for every point of the absolute value. This is a vertical stretch, but think of vertical stretch as a slope change. If this value were 1/2, it would go up 1 and over 2. So that would be more of a shrinking vertical change. All right, now if I incorporated a negative into here, what if I said -2? Well, if I said -2, we would still have the same coordinate, but now it would flip and have a range of 2 down and 1 over that way. Okay, so with this, there's 2 types of problems. We can have a negative, or we can change the value of the slope, or both. Okay, so keep that in mind. Now, with all that said, we can have a combination of them. And what's important now is what happens to the vertex. Because if we can graph the vertex and we know the slope, then we can graph this particular function, or we can tell the movement of the function. So up here, the vertex is going to be represented by hk, and the whole graphing function is represented by a absolute value of x minus h and then plus k. All right, so in this function here, our vertex is going to go right 2 and up 1, indicated by the translation notations here in our function. This 3 outside is going to tell us that our slope is going to go 3. So from the vertex, we're going up 3 and over 1. So if we go 2 over 1 up for our vertex, our slope is 3. This would be our graph. Okay, so absolute value shifting is actually quite easy, but again, when it's all said and done, think about the vertex of what's going on. So if we come back here to our original, the h value is 0 and the k value is 0, so our vertex is 0, 0. If we look at this example, our h value is 0 and our k value is 2, so our vertex is 0, 2. If we look at this example, h is 4, remember it's the opposite of h, so h is 4, and there's no k value, so it's going to be 4, 0. If we look over here, again, it's 0, 0. And if we look at this one again, it's 0, 0. So pay attention to domain, range, the vertex, the slope, how things are changing. And it's actually quite easy once you go through some of these problems. But these rules are going to apply to future function families that we do in upcoming lessons.